Hey everyone. Man, what an absolutely chaotic week it's been in the cybersecurity world. We've literally had multiple critical vulnerabilities dropping all at once. But for this explainer, we are going to hyper-focus on one massive zero-day in particular known as wp2shell. Now this isn't just your run-of-the-mill bug. This is a pre-authentication remote code execution flaw sitting right smack in the middle of WordPress core. We're going to break down exactly how wp2shell exploits this core architecture, taking you from the macro threat landscape all the way down into the microscopic PHP code. And of course, we'll talk about what you absolutely need to do about it right now. Okay, let's dive right in.
Here is our roadmap for today. First, a week of urgent patching. Second, we'll look at the wp2 shell threat scale. Third, the anatomy of the exploit chain. Fourth, we'll dig into the array desync bug. And finally, number 5, mitigating the core threat.
All right, kicking things off with Section 1, a week of urgent patching, where 2 massive 0 days drop at once.
So security teams are dealing with 2 massive headaches right now. On one hand, we've got Windows Legacy Hive. This is a pretty nasty bug in the user profile service that basically allows a standard user to load another user's registry Hive and potentially get full system compromise. But, and this is a really big but, it's a local privilege escalation. The attacker already needs to have access to the machine. On the other hand, we have WordPress wp2shell. This one is a pre-authenticated remote code execution. That means attackers need absolutely 0 prior access. No login, no special configurations required to exploit it over the internet. That remote, unauthenticated nature, yeah, that makes wp2shell a literal drop everything and fix it emergency.
Moving on to Section 2, the wp2 shell threat scale. Let's talk about the blast radius of a default API.
Think about this number for a second. 43%. That is the percentage of all websites on the entire internet powered by WordPress. We are talking about roughly 500 million instances sitting directly in the potential blast radius of this vulnerability. And because this flaw exists in WordPress core itself, not just some random, obscure third-party plugin, the exposure surface is just absolutely enormous. When a core system that powers nearly half the web has a fundamental flaw, trust me, the whole internet feels the shockwave.
To put that into perspective, this vulnerability boasts a critical CVSS score of 9.8 out of 10. Again, 0 authentication is required to exploit it. It targets the default REST API batch endpoint, which essentially means a stock, out-of-the-box WordPress installation will just answer the malicious request without you having to configure a single thing. In fact, this is so severe that the WordPress maintainers did something they very rarely do. They pulled the big lever and triggered forced automatic updates across the entire ecosystem to push the fix out. That action alone really tells you everything you need to know about how the project reads the risk level here.
Which brings us to Section 3, anatomy of the exploit chain, because 2 bugs are definitely worse than 1.
The wp2shell attack path is actually a chain made up of 2 specific CVEs. First up is CVE 2026-6137. This is a SQL injection vulnerability found in the wp_query class, specifically tied to the author_not_in parameter. The second one is CVE 2026-603030, which is a route confusion flaw tucked inside the REST API batch endpoint. On their own, each of these is somewhat bounded, but when you chain them together like dominoes, an attacker can use that route confusion to completely sneak past permission checks, trigger the SQL injection, and escalate the whole thing into full remote code execution. Now, to really grasp how this happens, we have to define what route confusion actually is. It's basically a vulnerability where an application routes a request to the completely wrong handler, bypassing any intended security or permission checks along the way. So, the attackers aren't forcefully breaking down the front door. Instead, they're tricking the system's internal traffic cop into waving them right through the VIP entrance. It's a really elegant manipulation of internal logic rather than just brute force.
Let's look closer at that logic in Section 4, the array desync bug. This is the microscopic flaw causing all this macro destruction.
So, the WordPress batch API is designed to let a client bundle a bunch of different REST calls into one single request. To exploit this, the attacker starts by sending a crafted batch where the very first subrequest is intentionally malformed. For example, they might send a totally broken path like http://. This purposely triggers an early WP error in the processing loop. But because of a logic flaw in how WordPress handles that early error, the internal arrays that are supposed to be tracking all the subsequent requests become misaligned. And that misalignment? That's the master key. That's what allows the attacker to completely bypass the permission checks for the rest of the batch.
Under the hood, WordPress is keeping 3 parallel arrays to process these batch requests: $requests, $validation, and $matches. When that early WP error we just talked about is triggered, it correctly gets recorded in the $validation array. But here is the fatal flaw. It is entirely skipped and not added to the $matches array. This creates a critical off-by-1 bug, meaning $matches is now 1 element shorter than the $requests array. So these arrays that are absolutely supposed to map cleanly to one another, they are now fundamentally out of sync.
If that sounds a little dense, think about it like this bouncer analogy. Imagine a bouncer at a club checking IDs against a VIP guest list. The very first person in line hands over a fake ID and gets kicked out. But the bouncer forgets to cross their name off the clipboard. Now, person number 2 steps up to the front, but the bouncer checks them against the name and the permissions of person number 1. From that exact moment on, the entire line is completely out of sync, and everyone gets waved into the wrong VIP rooms. That is quite literally what is happening inside the WordPress core memory when it processes these batched requests.
So in a normal, expected flow, request 2 is perfectly checked against handler 2's permissions. But during the exploit, because that array is shifted by 1, request 2 is actually being evaluated against the route and permission callback of handler 3. The attacker just brilliantly orders their batch of requests so that a benign, low-privilege request passes a highly privileged permission gate. And once they are successfully through that gate, they just steer the execution right into that SQL injection sink we mentioned earlier, and boom, straight to code execution and total system takeover.
Which brings us to this incredibly sobering quote from Strobe Security. The question is not whether you have it. The question is which of your instances an attacker can actually reach and run code on right now. Because this is a default pre-auth vulnerability living right in the core, you just have to assume you are exposed. Your priority right now isn't debating whether you're vulnerable, it's rapidly discovering which of your instances are reachable from the outside world before the attackers find them first.
So let's talk about how we fix this in Section 5, mitigating the core threat. It is time to secure the perimeter immediately.
Here is your game plan for remediation. If you are running versions 6.9.0 through 6.9.4, you need to update to 6.9.5 right now. If you're on 7.0.0 or 7.0.1, you need to go to 7.0.2. And hey, even if you are on the older 6.8 branch, you still need to update to 6.8.6 to patch that SQL injection portion of the chain. Now remember earlier when I mentioned forced automatic updates? Listen, you cannot blindly trust them. Background updates can and do fail silently, maybe because of file permissions, disk space issues, or some weird custom host configurations. You absolutely must manually verify the running version on every single internet-facing site you own.
Now, if you are in a situation where you cannot patch immediately, you need to deploy emergency WAF mitigations. You have got to keep anonymous callers off that batch endpoint. But pay close attention to this detail. You must block both the standard path, which is /wp-json/batch/v1, and the query string version, which is /?restroute equals batch/v1. If you only block the path, you are leaving that query string route wide open to attack. Alternatively, you could just disable unauthenticated REST access entirely, but definitely be aware that doing so might break some of your legitimate site integrations.
I want to leave you all with a bit of a provocative question to chew on. Does your security program actually see what attackers see before the next 0-day drops? Look, wp2shell is going to be patched and forgotten soon enough, but this pattern of critical flaws in ubiquitous software, that is for sure not ending here. Doing point-in-time scanning just isn't cutting it anymore. We need continuous exposure management to actually discover, validate, and close down our attack surfaces. If it takes your team days just to figure out where WordPress is even running on your network, well, that is the exact gap you need to start closing today. Thank you so much for joining me for this explainer, and please, stay secure out there.